Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today, I'm with two special guests, Nick and Brandon. Can you two introduce yourself?
Hi, my name is Brandon Barbello, and I'm the co-founder and COO of Archetype AI.
Hi, I'm Nick Gillian, and I'm also co-founder and head of AI and software at Archetype.
So, like the big hot stuff right now in industry is like all the buzz is around like ChatGPT. So, how are people like using that and then integrating like chatbots into the physical world? That's something I've always had a great interest in was merging like software with hardware. Like, what do people usually do in the past in that regards?
Sure, I think we could maybe break this down into three major phases. There would be these kind of three waves that we see folks go through. So the first wave was really text only, text in, text out, right? When the initial ChatGPT came out and similar chatbots, it was very much this kind of synchronous. You ask the system a question, it gives you back an answer. The input is text, the output is text. And that was exciting. And we saw things move very quickly. Then the second wave is starting to move into this multimodal in, multimodal out. You had a lot of kind of the VLMs coming out, other versions of the GPTs, things like Gemini and so forth. And there you could prompt the system with both text, but also maybe an image, or you could actually speak to it directly through a microphone. And it might be able to give you both text out, but maybe also draw you an image or give you a multimodal output. And it's still quite synchronous, right? You still have to take out your cell phone, snap a picture, send it to the model, ask a question, get back an answer. That's useful. But I think we're starting to move into this third wave now that we at Archetype have been working on for a while, which is starting to get us into this more kind of physical AI, which is less you point and shoot. It's less that you take a snapshot of data and send it to the model and get back an answer, but where you have sensors in the world and they're continuously going into the model and you're continuously getting feedback with the model. You're constantly interacting with it. So I think each of these phases has been extremely exciting and very useful. And definitely the power of these foundation models is really helping. There's a big step function in the last few years. But I think as we get towards more interactive systems where you have maybe a live camera that's streaming or all of the sensors from your house or these other things, that for us is really where this area is going and what we're particularly excited about.
So how does that work exactly? Because language models, they require a lot of resources, right? They require like big old GPUs. Are people using distilled models? And so that's a distilled model is a much smaller model than like your big world models. Are they using these like smaller lightweight models in order to do the inferencing? I'm assuming like closer to the where the sensor is so that you can decrease the lag. Like how does that work?
Yeah, we see both cases in the industry. There's definitely cases where you just have these massive data centers with huge GPU racks in them, and they're processing large text models in exactly the same way that they're really processing a video based model or maybe an audio that's streaming in real time audio and streaming out real time audio. And there, people are really just optimizing the pipe as fast as possible to get data in and out. But there are definitely some either resource constrained use cases or use cases where they're very time sensitive. Maybe if you think about the case of a safety use case on a robot, for example, or in a factory where you have a forklift and you don't want it to crash into one of the humans working on the forklift. There, you really need smaller models that run either on the edge or directly in the forklift itself to really minimize that latency and make sure that there's always a connection to the model so that for safety reasons, that 100 millisecond delay could be the difference between someone getting injured or the alarm going off and avoiding that accident. So we see both.
Is it just mostly in like the manufacturing space that you're seeing a big investment of like physical AI, or like what are there other like industries that you've seen that has a big push? I have to assume like manufacturing is like probably like the first industry that really adopted it.
Manufacturing is one of the largest, but we also see a lot in automotive, in fields like construction, fields like insurance, even. In general, anywhere there are already lots of sensors deployed and thus lots of sensor data. A key part of this current wave is that the physical world is not best understood through text and not best understood exclusively through visual data. And so these industries that have lots of data and lots of multimodal data have teed themselves up well for this next era where These new foundation models can serve as tools to analyze all that data together and do so in a way that understands the world natively, such that these models can consider time and space and perceive the world in ways beyond what people can.
Is there any interest in from the weather folks? I've always wanted to know if I can get the weather, at least the weather prediction, a little bit more correct. Is anyone in the meteorology department using physical AI?
Uh, we've had quite a few discussions about weather. One domain has been productivity impacts to construction. Another one has been climate and risk modeling for the insurance space. Independent of the work that we've been doing, folks like Google in the past few months have put out really exciting papers about what's becoming possible. I think how we see it is that weather and the climate is one of the most complex systems on the planet. And so it's a thing I'm excited about physical AI being able to scale into, but I wouldn't say it's been fully solved yet.
I think we see two interesting things on weather. One is, as Brandon mentioned, folks that really want to push the state of the art in terms of how to get more precise weather predictions or maybe get the forecasts further out in the case of insurance, for example, like to really predict the impact of that storm on an area, for example. But the other use case we see is customers that almost want to treat weather as another type of sensor. So it's almost like the weather is itself a sensor that you can then plug in as an auxiliary input into their physical AI system to really help understand that impact of the weather on their construction or the productivity of the site or other use cases. So I think taking some of these advances in other areas and almost thinking of them as virtual sensors is a pretty interesting way to think about all of this rich real-time data that we have in the world. Some of it is coming from a raw sensor, and some of it is maybe the processed output of another AI model, which can be the auxiliary input to these big physical AI models.
I like the idea of that because I did remember like a while back, like Uber, the taxi business or the rideshare business, they were just using data from like the riders and then the drivers. But then the moment that they started playing around with like weather data, they had much more refined pickup and drop off patterns. So I really like the idea of using weather as like another form of data that's like adjacent to like your primary form of data collection. I, again, a lot of companies, in my opinion, I think a lot of companies are in like the logistics, agriculture, commerce, like they all rely on weather data because that greatly affects like the way that they move their products. So are there any other industries that are like adding weather data that are outside that it's like outside the norm that you're seeing? I'm always fascinated with like how people use weather data.
Not specifics I can name, but I think you're onto it that weather is a context signal and one that humans respond to, whether or not the thing they're concerned about is in the weather. And I would not be surprised if over the next few years, it becomes a baseline signal that's used in any kind of analysis of human or machine behavior in the physical world.
And then speaking of just sensor data, you guys play around with like camera, like computer vision stuff on your platform? Yes, I'm a big like CV guy, and I'd say like like over a decade ago, like researchers finally figured out that like you could use vision data as unstructured data, and that opened up a world of like possibilities as to this just immense of amount of like just video footage. So how are people using with the physical sensors such as like computer vision to extract out information? What's the go-to right now? Is it like object tracking, segregation, like object segregation? What's like the go-to thing that people are doing?
Yeah, cameras are definitely one of the kind of primary sensors we see a lot from our customers that come to us. And some of them are they want to take the more traditional computer vision style pipelines and see how far they can push them in terms of object detection and tracking. But I think one of the areas that more modern models are starting to unlock is this ability to do stick detection, for example, on a video, right? For instance, you can ask a question, which is maybe less of detecting a class like a person or a car or something like this here. It's more notify me in the camera if you see any like unsafe behavior, for example. Like, what does unsafe behavior mean? That's a quite ambiguous search term, right? But this is something that these new versions of foundation models are starting to unlock, right? And I think customers are getting pretty excited about that because it means that you don't have to sit down for a year and define your data collection plan and all the classes you want to build for that one use case. The models are actually now on the fly. You can basically define what these things are you would like to detect. So even if you want to apply this to a more traditional like object detection scenario, now you can actually do semantic object detection instead of the more classic, I have 100 classes in my model and it can only detect those 100 classes. So I think that's one use case we see with cameras. The other one, which is I think quite different to previous computer vision techniques, is how do you actually think about a fleet of cameras around a factory or around a building or around a city, for example? And how can you project all of that into a single virtual representation of the world where the model actually starts to understand if there's two cameras looking at the same intersection, for example, that this is the same car, this is the same person on the bicycle. And now you actually are capturing it from two different angles. So you actually can improve your tracking and detection abilities by fusing those cameras together. So I think this is quite different, I think, than a lot of computer vision systems in the past, with the exception of those systems that are explicitly built for a certain number of cameras in a certain position, and every time you move them, you have to recalibrate it and all this stuff. Like now we're getting to the point where you can just plug multiple cameras into a single foundation model, and the model can fuse these across space and time. And that's very powerful. That really starts to unlock some pretty exciting things that we couldn't do in the past.
Yeah. Is that easier to do now? Because back in the day when I was in computer vision, like in the computer vision area, like one of the hardest things was like the multi-camera, multi-object tracking. That was like the creme de la creme. So like a use case would be like you're in the airport and there's two cameras pointed towards each other, and then like a person walks through it, and they're trying to track it for like national security, like a use case. Or even you're like going to a gas station, there's cameras tracking your car going into the station and tracking you going into the store and buying something in the store. So it's like being able to path out the customer journey during a store. That was one of the hardest things that you could do in computer vision. Has that gotten easier with using generative AI and like the combination of computer vision with generative AI, or is that still very difficult to build out?
I wouldn't say it's got easier. It's still, from an engineering perspective, extremely difficult to build these systems. But the power of the self-supervised approaches that we get with foundation models, and actually now starting to build a general foundation model where you can plug in different combinations of sensors, for example, or you can train them in the gas station that you mentioned, but then maybe apply them to a coffee shop or maybe apply them to a supermarket or something else, and the model can generalize. I think from the customer's perspective, it's got easier. But maybe from the engineering perspective, there's still a lot of deep knowledge required to really look at how to plug in multiple cameras and have this generalized. And also just from an engineering perspective, how do you stream 100 cameras into a single foundation model and fit all of that in memory? And how many GPUs do you need to run that on? So I think there's still quite a few engineering challenges, but maybe for the customer, it's got a lot easier now that these models are starting to converge and they can be used.
So yeah, I was told you guys like raised some money from Venrock. Can you like tell us some stuff about like your fundraising like stage and then who backed you guys? And I don't know if you can just disclose it, like how much you guys raised.
Sure. For the seed round, we announced this past spring, we had raised $13 million. Venrock was the lead investor, and there were follow-on investors like Hitachi Ventures and the Amazon Industrial Innovation Fund, as well as a series of smaller investors who are friends around the AI community.
So for early use cases, you guys built out some cool stuff around vehicle situational awareness. Can you guys disclose what that was?
Yeah, we can share a little bit, but yes, two of our first projects were in the space. The first one was really neat. So in both cases, we built one foundation model. Newton is the model's name, and that same base model can be adapted to each of these different use cases. So in one, it was work with a startup that was building like an automated version of Waze, where for every user of this app, their phone can behave as a dash cam. And then Newton is looking at those video streams. And as Newton sees road hazards, say construction sites or accidents, that all gets plotted on a shared navigational map. And so this we thought was a great example of the kind of thing that Nick was describing for what you can do with multiple cameras. It's almost like every driver makes every single additional driver smarter. And this data, of course, is useful for automated routing for fleets, for reporting to smart cities of what's happening. It's almost like a real-time kind of crowdsourcing of what traffic conditions are. And then for the other project, what we can share is there's lots of car makers that have now deployed a lot of vehicle sensors, both inside as well as outside, as well as that might be used across multiple vehicles. And so there's really interesting things you can do when you think beyond self-driving about what these cars can be continuously aware of, especially regarding human behavior around the vehicle or inside the vehicle, and the kinds of proactive actions these cars can take for convenience, for comfort, for personal security. These cars come much more alive when they can take advantage of all this new sensing power.
Does the inferencing there, is that local, or do you send it off to the cloud and then that does all of the computing remotely? Like, how does
This is
that work?
This is also a very exciting point. So, a lot of the vehicles that are just coming out now are beginning to have enough of onboard GPU compute to run these models. And you might do some things in the cloud, you might do some things across fleets, but individual vehicles can now run a lot of their experience locally for latency and for privacy reasons.
Wow, that's crazy. I did hear reports about Elon Musk, the owner of Tesla, wanting to like use like Teslas that were charging and idling as like a remote computing module or something like that. I didn't realize that a lot of the more modern cars had that much power on them that they could just run things locally. But it seems like you guys are seeing the same thing where you can actually run inferencing locally on these on your vehicles now.
One that was mentioned in an article in Wired was Volkswagen, but there are a few others now too. What we're enabling with Newton is that any development team that has lots of sensor data, but is resource constrained, maybe they don't have a lot of data, especially if it's customer sensitive, or maybe the team isn't super big. A model like Newton can serve as a tool for them to build their applications faster. And so the goal is to accelerate all these development teams trying to build the next generation of these AI sensing systems.
And it looks like you guys have another use case that's pretty cool. What about like home safety? Can you guys talk a little bit about that?
Sure. Yeah, home security is also really interesting. I think we all have experience with these cameras that detect just a few things and they're a little bit flaky. And often they'll detect something, and true or not, you take a look and you're trying to figure out what happened. You can't just ask it. You can't just talk to your house or talk to your cameras. And so the ability now for these models to combine all the different things that all the different sensors across all the different devices know is really interesting. And there's obvious ones like cameras, but there's also interaction with devices that are within the home. There's even ideas around things like network traffic as a kind of signal that are also indicative of what is going on, who's around, what devices are doing certain things. I think I want to call out on the topic of what folks are doing with sense data in the physical world, though, is that a home is a great example of an environment where maybe you're okay with cameras on the exterior, but on the interior, you don't want to deploy a bunch of cameras. And an approach like ours, being so multimodal, lets you choose alternatives. Some might choose, for example, to use radar sensors, which can be much more privacy preserving and thus have this mix of sensors across a physical space that can use radar in the inside and cameras on the outside to have this holistic view of what's going on in and around a person's home.
I think this use case is pretty exciting. It goes back to what I was saying at the start, where in this third wave, where we're going beyond VLMs, where you hold out your cell phone and you take a picture and you send it to the model and ask it a question. What recipe can I make with these ingredients or something? It's quite, the user is directly in the loop. I think what Brandon's alluding to here in the home safety and security space is a great example of where you have all these sensors around your home already. Some of them could be cameras on the outside. You could have a bunch of sensors on the inside. Maybe even things like your fire suppression system and stuff. Like all of those sensors could be plugged into a single model, and that model is constantly understanding your home and your routine. And it understands that maybe on a Friday, like that's when the trash is taken out, or that's when the gardeners come, or things like this here. And the model can pick up on these patterns and start to understand them. And you don't have to keep asking the model, like, did my package arrive? Did my package arrive? Did my package arrive? You can simply like almost talk to your house, right? The way you would do with a chat GPT. You can just talk to your house as a single entity. And these sensors, because they're all multimodal, they can be fed into one model that can help make better sense of what's happening around your home. And then you can use that for things like just improving your quality of life a little bit in terms of, did your FedEx package actually come on time or not? Or maybe more in the safety area, or if the carbon monoxide alarm goes off at 2 a.m., is that a false positive, or were there other signals from other sensors that actually indicate, no, this is serious? You need to get out of bed and get out of the house and open all the windows because there is actually something else going on, right? I think this type of area, either around the home or in more of the enterprise areas where we can fuse many sensors. Cameras is one, but you can think of temperature sensors and gas sensors and even the voltage that's going through the outlets. All of that, they have some form of information about what might be happening in the world. And by combining them all into a single model, we can make better sense of it and then help people make better sense of the world. So I think this area is pretty exciting of how we can take all of these sensors now and put them into a single model for the first time to actually make better sense of the world.
So like this Newton platform that you guys built is really cool. Can you just tell me a little bit more about that?
Yeah, so at the core of Newton the platform is Newton the model, this massively multimodal foundation model for understanding the physical world through sensor data. And it combines sensor data with natural language, which makes it possible to give this model instructions for what you want done with that data, and for the model to communicate back insights about that data, or to take actuation or generate visualizations, whatever's best for the operator to better understand the world around them. And then the Newton platform that wraps the Newton model and provides a series of tools for developers that have sensor data to very rapidly build an AI solution. And very key here is that our goal is that you shouldn't have to have expertise in AI. You shouldn't have to deal necessarily with sensor streaming or GPU or orchestration. We want to make it as simple and easy as possible for any developer to build a solution to real life problems.
And for our viewers at home, in case like they're interested in learning more about Newton, what's the best way to get in contact with you guys?
If folks at home want to go to archetypeai.io, they're welcome to ping us a message there, and we'll be sure to respond.
So looking forward in the future, what's like the big hot thing that's going to happen with, say, generative AI and like the physical world? Like, what's your like prediction?
I think if you look at Jensen's keynote from CES last month, definitely the big trend he was predicting was this progression from generative AI into physical AI, which of course we Archetype we were very excited to see this given we've been working on this area since 2023. I think that if you talk with other folks, people are predicting areas like self-driving or robotics is going to be one key area. We are actually quite bullish on other critical areas of physical AI where people already have the sensors in the world and they want to basically make more use out of them. So there's a huge number of areas in things like we've talked about in terms of like safety and security and automation, and maybe in large factories, things like anomaly detection or being able to predict when you have to take that large $1 million machine offline to service it, for example. All of these critical areas. We see a lot of customers coming to us. They already have sensors. They already have key use cases. They've tried to build more classic machine learning techniques on top of this, but they have to restart every time they move the sensor or they slightly change the use case. So I think there's this whole area of physical AI where customers already have sensors in the world. They already have a key problem. And now there's this new solution that's come out of the blue where people can start to apply these foundation models to their problems. So I think we're going to start to see a lot of interesting applications in this space. And it doesn't require a new robot to be deployed or like a brand new self-driving system to be built into a car, which might take several years and so forth. So I think that's going to be one key area that we're pretty bullish on.
To piggyback on that, yeah, we're very excited about our approach, enabling developers to solve the problems that they have today. And in truth, they've had these problems for a long time. The reason there are all these sensors deployed is because of the IoT wave or the industry 4.0 wave, where large organizations made these investments, but the promise was not fulfilled. And the reason the promise wasn't fulfilled is that it simply was too uneconomical or too complex to build all these environment-specific solutions. What's great about a foundation model, Newton, or any other physical AI model is that you don't have to start from scratch. You can start here. And now with an incremental amount of data, or increasingly no need for fine-tuning, you can build a solution to your long-tail problem. Every warehouse has the same problems, but every warehouse is different. And so computer vision hasn't been robust enough. Or in a similar way, I might operate my construction site in this specific way. A general purpose solution someone else has built in a verticalized software fashion isn't going to handle that well. But so now with physical AI and foundation models, now every single one of these niche and long tail problems can be solved. And we think this is can result in a world where these things are truly ubiquitous, and this power is in anyone's hands to improve real life.
Building on what Brandon said, I think there's also another really interesting part of that, which is these approaches that people have tried for the last 5 or 10 years in these previous waves. It means that customers not only have a large number of sensors deployed in their systems that they want to squeeze more out of, but they also potentially have many years worth of data from real incidents in their factories or from real weather patterns around the world for rare events or for this maybe very unique part that only this one factory in a certain part of the world makes, and it's not on the internet, and it's very hard to get. And because of the value of physical AI foundation models, and also particularly self-supervised learning, these customers that have these recordings, it could be camera data, it could be more time series data, it could be other form factors. This really actually unlocks this new value for them that they might not have known they've had. So all of the things that they've tried before in the IoT wave, maybe it wasn't so successful now, but because they have these data sets, this really actually gives them this new proprietary data set that only they have, that they can now plug into models like Newton and they can fine tune on top of to very quickly build the best model in the world for their use case, for their type of sensor. And I think that's really exciting for these customers that have tried these previous approaches. And actually, it's really set them up for success now that physical AI is here.
And then for our listeners who are like really interested in like physical AI, what's a good place where they can get started?
I think our website has some good blogs on it, which if people are looking for high-level introductions to what physical AI is and the different areas, the different aspects. There's also recent talks. I just mentioned Jensen's talk from CES last month. It's a pretty good overview on different areas of physical AI. NVIDIA recently, released a pretty interesting paper on their Cosmos work. So there's definitely a lot of excitement in this area. I think a lot of companies are starting to move towards this third wave of being able to take many different types of sensors and then plug them into a model which is constantly analyzing the world. Yeah, I'm pretty excited about this direction and where it's going.
Thanks so much for being on the show. And until next time, stay curious.